Okay, so you've pulled together a really interesting set of resources for us today. Looks like a deep dive into the world of Microsoft Azure.
That's the plan.
We've got some sample questions here that really make you think, plus some pretty solid reference documentation alongside them.
Yep.
So our mission, basically, is to pull out the essential knowledge from all this, give you, the listener, a much clearer picture of those key Azure concepts. Think of it as maybe your express route to getting well-informed.
Exactly. We're aiming to cut through the noise, and highlight what really matters for understanding Azure.
Okay.
We'll be exploring everything from the foundational ways you can set up your cloud presence, the different types of services available,
Right.
how to manage costs effectively, which is always huge, then the crucial aspects of security, and how to make sure your applications are always up when you need them.
Availability, yeah.
Expect hopefully some light bulb moments as we unpack all of this. Let's maybe kick things off with those cloud deployment models.
Okay.
The materials clearly outline three main types: public, private, and hybrid. What are the core differences we need to sort of get our heads around?
Okay, let's unpack this, the public cloud.
Yeah.
As our sources really emphasize, it's the most common model, right?
Seems that way.
The really significant thing here is that you don't have any on-premises hardware to worry about at all.
Right. No physical boxes in your server room.
Exactly. Everything runs on the provider's infrastructure, Microsoft Azure in this case. It's like, I don't know, using a shared utility service for electricity versus having your own generator.
Good analogy.
Key features include that metered pay-as-you-go pricing. You only pay for what you actually use.
Which is a big draw.
And there's also a strong element of self-service management, giving you control to deploy and configure your resources as you need them.
So you spin things up yourself.
Yeah. And one of the big implications highlighted, which is pretty major, is that a company fully embracing the public cloud could potentially shut down its own physical data centers.
Wow, yeah. That's a huge shift in infrastructure, a fundamental one, really. Now, if public cloud is like using that shared utility, what about private cloud? What's the core difference there?
Right. So we understand public is all on Azure's gear.
Yeah.
What then defines a private cloud?
A private cloud, well, as the name kind of implies, brings that cloud environment directly into your own data center.
Okay. On-prem.
Exactly. You still get that self-service access to computing resources for your organization's users, which is, a key characteristic of cloud computing. But the crucial distinction is that your organization remains responsible for all the underlying hardware and software. You're basically building and maintaining your own cloud infrastructure.
So you buy the servers, the storage, everything.
Yep. As the documentation points out, you're still responsible for the capital expenditure and the ongoing maintenance of everything. So that idea of closing your data center, pretty unlikely with a private cloud setup.
Right, that makes sense. So public is leveraging Azure's hardware. Private is all within my own infrastructure. That leads us, naturally, to hybrid cloud. How can we best understand that model?
Think of hybrid cloud as a strategic blend, really. It combines your on-premises private cloud with the resources of a public cloud like Azure.
The best of both worlds. Maybe.
Sometimes, yeah. It allows organizations to extend their internal networks and computing capabilities into the public cloud, often through secure VPN connections.
Okay.
This is particularly valuable when you need, say, additional capacity for peak times, or you want to modernize without a massive upfront investment in new on-prem hardware.
So burst capacity, things like that.
Exactly. Instead of buying more servers for that busy season, you can tap into Azure's scalable resources. The sources also clarify that you can indeed have physical servers in both private and hybrid cloud environments.
Which makes sense, yeah.
Given that part of the infrastructure remains on premises, it's also important to remember, as the docs state, that the public cloud is a shared environment used by loads of organizations at the same time.
Right, multi-tenant. Okay, that makes perfect sense, a flexible combination. One point I noticed in the materials was a specific clarification about private clouds and internet connectivity. Could you elaborate on that?
Certainly. Yeah, there's a common misunderstanding that private clouds are somehow totally isolated from the internet. air-gapped or something.
Right.
The sources explicitly address this, stating that's not necessarily the case. Private clouds can be, and in most practical scenarios are, connected to the internet.
Ah, okay.
The private aspect really refers to the ownership and the management of the physical infrastructure. It's dedicated to a single organization, not necessarily its connectivity to the outside world.
That's a really important distinction to clarify. Good point. Now, let's shift our focus a bit to the different types of cloud services Azure offers. We have that fundamental trio: infrastructure as a service, right? So like platform as a service, PPay, and software as a service, SIBS. Let's begin with AS. What's the core concept here, and what's a primary example in Azure?
Okay, infrastructure as a service, IaaS. Azure Virtual Machines, VMs, are the classic example here. IaaS provides you with the highest degree of flexibility and control over your underlying IT infrastructure in the cloud.
Okay, the building blocks.
Pretty much. Think of it as providing the essential building blocks: servers, storage, networks, even the operating systems. Instead of buying and managing this physical hardware yourself, you essentially, well, rent it from Azure.
Right.
What's particularly interesting is the division of labor. Microsoft handles the physical stuff, the data center security, replacing failed disks, all that.
The hardware layer.
Exactly. While you keep control over the operating system, backups, patching, and the security of your applications running on those VMs.
So I'm still managing the OS and what's on it.
You are. It's like renting a car. The rental company maintains the vehicle, but you're responsible for driving it safely and, locking the doors.
Okay, so I'm managing the software and OS on rented infrastructure. That makes sense. Now, what about PaaS? The sources highlight Azure App Service and Azure SQL databases. How do these differ from IaaS in terms of what's managed?
Platform as a service, PaaS. This really elevates the level of abstraction. Solutions like Azure App Service for web apps or Azure SQL databases, they provide a complete environment for developing and deploying applications in the cloud.
More than just the infrastructure, though.
Oh, yeah. This includes not just the infrastructure servers, storage, networking, but also middleware, development tools, BI services, database management systems. The whole platform, really. It's designed to streamline the entire application lifecycle: building, testing, deploying, managing, updating. The key difference from IaaS is you have significantly less control over the underlying infrastructure because Azure manages more of it for you.
Less admin burden for me.
Potentially, yes. As the sample questions correctly point out, using Azure VMs with SQL Server installed, well, that isn't pure PaaS.
Because of the VM part.
Exactly, because you still have that IaaS component of managing the VM itself. And it's also worth noting, the docs mention Azure storage accounts are generally classified as IaaSs as you're mainly interacting with the storage infrastructure.
Yeah.
Think of PaaS maybe like a ready-to-build website platform, the hosting, OS. Basic tools are all provided, so you can just focus on creating your content or your application.
That really clarifies the distinction. Less management overhead for me with PaaSers for web apps and databases, sounds like.
Yeah.
Now, let's look at the final piece. SASA, email, and Microsoft 365 are mentioned. What's the defining characteristic of SaaS?
Software as a service,
Right.
SaaS, is where you, as the end user, simply connect to and use cloud-based applications over the internet. Common examples are things like email. Microsoft 365 is a big one. Calendaring, maybe CRM tools, office productivity tools.
Stuff I use every day.
Exactly. You essentially subscribe to use the application, often on a pay-as-you-go basis. The critical aspect here is that provider Microsoft, in the case of M365, manages all the underlying infrastructure and the software.
Everything.
Pretty much everything behind the scenes. You just consume the service, usually through a web browser or maybe a dedicated app. Think of it like using Gmail or Outlook.com. You just log in and use it. You don't worry about the servers, the software updates, or anything else.
So IaaS gives me the most control. Then PaaS offers a managed environment, and SaaS is where the provider handles almost everything. The sources even give some guidance on when to choose each type, right? Strategically.
Exactly. Yeah, they do. For web applications, especially those accessed by external users, the sources suggest PaaS is often a highly effective way to minimize your administrative burden.
Makes sense.
Since Azure handles the infrastructure, middleware, patching, etc., you can really concentrate on your application's development and features.
Okay, in IaaS.
On the other hand, if you have highly customized applications with very specific prerequisite software, maybe legacy apps, things that need particular configurations at the OS level, then IaaS gives you that necessary deep control over the environment.
Got it. That's some really practical advice there. Now let's dive into a topic that's, well, always top of mind: cost. The materials discuss the shift from capital expenditure, CapEx, to operational expenditure, OpEx. Can you explain what this means for someone moving to Azure?
Certainly. It's a fundamental shift. Capital expenditure, CapEx, refers to those significant upfront costs you incur when you buy infrastructure, outright things like buying physical servers, building a data center. It's a big initial investment.
In a traditional way.
The traditional IT model, yeah.
Yeah.
Operational expenditure, OpEx, conversely, represents the ongoing costs of running your IT environment, things like software licenses, staff salaries, and crucially here, the consumption-based costs of cloud services.
Pay as you go.
Exactly. Migrating to the public cloud largely shifts your financial model from that upfront CapEx to a more flexible, ongoing OpEx model. Instead of buying servers, you're essentially renting compute resources and paying for what you use each month or hour.
Okay.
It's important to note, though, as the sources point out, even though reserved VM instances can save you a lot of money long-term, because you're making an upfront commitment and payment, that initial outlay, it's still classified as CapEx.
That's a really important nuance about reserved instances. Easy to overlook. What about the cost of the virtual machines themselves? The sources mention that VMs of the same apparent size can have different monthly costs. What drives that difference?
Yeah, that difference in cost for seemingly identical VMs often comes down to the storage configuration.
The disk.
Specifically, the type and size of the attached disks. While two VMs might have the same CPU cores and RAM, the type of storage they use, like standard spinning hard drives versus premium solid-state drives, or even ultra disks, and the amount of storage allocated will have different price points.
Performance costs more.
Generally, yes. Higher performance storage options like premium SSD or ultra disks will usually result in a higher monthly cost compared to standard HDD.
And what happens with billing when you stop a virtual machine? Are you still racking up charges?
This is a crucial point for optimizing your Azure spending, definitely. When you stop, and keyword is deallocate an Azure virtual machine, you indeed stop being charged for the compute resources that VM was using, the CPU time, basically.
Okay, good.
However, and this is the important bit, you do continue to be charged for the associated storage.
So the disks are still costing me money.
That's right. This primarily includes the virtual hard disks where your data lives, but it can also include storage for things like boot diagnostics data or any VM backups you've configured.
So just shutting down the OS inside the VM isn't enough?
Correct. You need to ensure it's fully deallocated through the Azure portal or command line tools to stop the compute billing. Otherwise, you're still paying for the reservation, essentially.
That's a very practical tip. Now, for organizations trying to, get a handle on their overall Azure spending, what tools or features does Azure provide? Azure Cost Management is mentioned.
Azure Cost Management is really indispensable, especially for organizations with an enterprise agreement, EA, Microsoft Customer Agreement, MCA, or a Microsoft Partner Agreement, MPA.
Okay.
It offers a comprehensive suite of capabilities to help you effectively plan, analyze, and, crucially, optimize your cloud spending. You can track spending trends, set up budgets, get alerts.
Like if I'm about to go over budget.
Exactly. And identify specific areas where you might be able to cut costs. Think of it as your central dashboard for understanding and controlling your Azure finances.
The materials also mention using resource tags. How do they help with cost management?
Resource tags are basically metadata labels, key value pairs that you can apply to your various Azure resources.
Like tagging a VM with Project X or Dev environment.
Precisely. By strategically tagging resources based on criteria relevant to your org department, project, cost center, environment, you gain the ability to easily filter and group your cost data in Azure Cost Management.
So you can see which department is spending what.
Exactly. It allows for much more granular cost accounting and reporting. Super helpful for chargeback or showback. One important thing to remember, though, tags are not automatically inherited from the resource group they're in. You have to tag the resources themselves.
Good to know. And what role does Azure Advisor play in helping manage costs? I know it gives recommendations on various things.
Absolutely. Azure Advisor acts like your personalized cloud optimization consultant, and cost management is one of its primary areas.
Okay.
It continuously analyzes your Azure resource configurations and usage patterns, and proactively gives you recommendations on how you can reduce your overall spending.
Like what kind of thing?
It might identify VMs that are idle or way underutilized, suggest opportunities to right-size your compute resources to better match your actual workload, or highlight potential savings from using reserved instances or savings plans.
helpful suggestions.
Yeah.
What about resources that you might have provisioned but aren't actively using anymore? Are there often hidden costs there?
Yes, there definitely can be. For instance, as the docs point out, you are charged for public IP addresses as long as they're allocated to your subscription, even if they aren't currently attached to a running VM or service.
Oh, really? Even if unused?
Yep. However, you're generally not charged for unused network interfaces, NICs, or for inactive Azure AD user accounts or groups. So it pays to regularly review your resources and clean up anything that's no longer needed. That avoids those unnecessary, often overlooked costs.
Good housekeeping pays off. Lastly, on cost, the sources mention Azure reservations as a way to potentially save money. How do those work?
Azure reservations offer a way to get significant discounts, sometimes up to 70% or more, compared to pay-as-you-go, by committing to use specific Azure resources, like VMs or SQL database capacity, for a set period, usually 1 or 3 years.
So you commit up front.
Exactly. In exchange for that commitment, you get a substantial discount. This is particularly good for workloads that are predictable and run consistently over the long term. Stable stuff.
Okay, we've covered a lot about keeping costs under control. That's crucial.
Yeah.
Now, let's pivot to another fundamentally important aspect, availability and reliability. The materials talk about Azure regions and availability zones. What are these, and why are they so critical for keeping my applications online?
Okay, yeah, super important. Azure regions are essentially geographically defined areas around the world that contain one or more data centers. Microsoft has tons of these regions.
Like West US, East US, West Europe.
Exactly. They're designed to be close to users to minimize latency. Now, to boost resilience within a region, many are further divided into availability zones, or AZs.
Zones within a region.
Correct. These are physically separate and independent data centers within that single Azure region. Each AZ has its own independent power, cooling, and networking infrastructure.
Physically separate. That's the key.
That's the key. And a crucial point, in regions that support them, there's always a minimum of 3 availability zones.
3 or more. Okay. So this physical separation between zones is what gives you that enhanced availability.
Precisely. By strategically deploying your resources, like your VMs, across multiple availability zones, best practice is usually at least 2 day 2. You achieve a significantly higher virtual machine uptime service level agreement, SLA. The docs state 99.99% for VMs across zones.
4 nines. That's pretty high.
It is. This multi-zone deployment protects your applications and data from failures that might affect a single data center, like a power outage or a network issue in one specific building. Your resources in the other zones should keep running.
That level of resilience sounds essential for anything critical. How does this compare to other options mentioned, like availability sets or dedicated host groups?
Good question. Deploying your VMs within the same availability set or on the same dedicated host group still provides redundancy. It protects against certain hardware failures within a rack or helps during planned maintenance.
But it's within one data center.
Exactly. That protection is generally contained within a single physical location or data center. Consequently, the VM uptime SLA for those configurations is typically lower, 99.95% according to the sources.
3 nines and a 5. Still good, but not quite 4 nines.
Right. And even a single VM, if it uses premium SSD or Ultra disks for its OS disk, gets its own SLA of 99.9%.
Okay.
It's also really crucial to understand, as the materials point out, that just putting VMs in different resource groups does not give you any availability guarantee across data centers.
Resource groups are just logical containers.
Right, exactly, for management. Similarly, deploying multiple VMs in a virtual machine scale set alone doesn't guarantee cross-data center availability unless you specifically configure that scale set to span across multiple availability zones.
Got it. Configuration matters. What about planning for bigger disruptions? Disasters. Azure Site Recovery is mentioned for business continuity.
Azure Site Recovery, or ASR, is a dedicated Azure service specifically for business continuity and disaster recovery, BCDR.
Okay.
It works by replicating your critical workloads, whether they're running on-prem, on physical servers, VMware, Hyper-V, or even in another cloud from your primary location to a secondary Azure region.
So you copy everything over.
Continuously replicates the changes, yeah. Then, if there's a major outage or disaster at your primary site, you can initiate a failover to the secondary Azure region, bringing your services back online there, minimizing downtime and potential data loss.
Essential for keeping the business running. The materials also touch upon fault tolerance, disaster recovery, and dynamic scalability. Can you quickly define those in the Azure context?
Sure. Fault tolerance is basically the ability of a system to keep operating even if a component fails. Think redundant power supplies, or like using availability zones. One zone fails, the others keep going.
Built-in redundancy.
Yep. Disaster recovery, as we just discussed with site recovery, is the whole process of recovering your services after a major incident or disaster wipes out your primary site, getting back up and running elsewhere.
Okay.
And dynamic scalability, which is a huge benefit of cloud, especially with things like VM scale sets, is the system's ability to automatically adjust its compute resources, add or remove VMs, for example, based on the current demand or workload. Scales up under load, scales down to save money.
Auto-scaling.
Yeah.
Got it. Just one final check on availability. Are availability zones available in every single Azure region globally?
No, not yet. The documentation is clear that AZ support is currently available in, let's say, select Azure regions, though the number is always growing.
Yeah.
It's always best practice to check the documentation for the specific region you plan to use to confirm if AZs are supported there.
Good advice. Check before you deploy. Okay, reliability and high availability, clearly paramount. Let's now turn our attention to another critical area. Security and governance within Azure. The source has introduced network security groups, or NSGs. What exactly are these, and how do they help secure my Azure stuff?
Network security groups, NSGs, are essentially, think of them as virtual firewalls at the network layer. You can associate them with either a subnet within your Azure virtual network or directly with individual VM network interfaces, NICs.
Okay, firewall rules.
Exactly. NSGs let you control the flow of network traffic, both inbound to your resources and outbound from them, by defining a set of security rules.
Like allow port 80 inbound.
Precisely. The rules specify source and destination IP addresses, ports, and protocols that are allowed or denied. This gives you really granular control over network access. For instance, a common use case is using an NSG to lock down a database server so it only accepts connections from your web servers on the specific SQL port and denies everything else from the internet.
Makes sense. So NSGs are focused on traffic control for subnets or specific VMs. What about Azure Firewall? How does that differ? Is it just a bigger NSG?
Not exactly. Azure Firewall is a managed cloud-native network security service. It provides more comprehensive traffic filtering and protection, but its scope is generally broader. It operates across multiple virtual networks and even across different Azure subscriptions if you set it up that way.
More centralized.
Yes, that's a key difference. Unlike NSGs, which are distributed and tied to specific NICs or subnets, Azure Firewall acts as a centralized, highly available security gateway for potentially your entire Azure network estate.
Okay.
It offers more advanced features too, like built-in high availability, automatic cloud scalability, threat intelligence-based filtering, and the ability to enforce both network-level and application-level filtering rules centrally. Think of NSGs maybe as security guards on individual building doors, while Azure Firewall is more like the main security gate and patrol for the entire campus.
That's a helpful analogy. Okay. The materials also mention Azure DDoS protection. What's its purpose? Sounds pretty self-explanatory, but...
Yeah, it largely is. Azure DDoS protection is designed to help safeguard your Azure applications against distributed denial of service attacks.
The ones that try to flood your service offline?
Exactly. Those attacks try to overwhelm your application's resources bandwidth, server connections with a massive volume of malicious traffic, making it unavailable to legitimate users. Azure offers two tiers, Basic and Standard.
What's the difference?
Basic protection is automatically enabled for Azure resources and provides, well, basic defense against common network layer attacks at the Azure platform level. The Standard tier, which is a paid service, offers much more robust and tunable mitigation capabilities specifically for your virtual networks.
Like what?
It includes adaptive tuning based on your application's traffic patterns, detailed attack analytics and metrics, near real-time telemetry via Azure Monitor, and even integration with services like Application Gateway Way. Plus, importantly, the Standard tier provides logging and reporting on attempted attacks.
So Standard gives you more visibility and control.
Okay.
Protecting sensitive information is obviously critical. Azure Key Vault is mentioned for this. What is it, and what kind of secrets can it handle?
Azure Key Vault is a dedicated, highly secure service specifically for storing and managing sensitive information, what we generally call secrets.
Like passwords.
Exactly. Things like administrative passwords, API keys, database connection strings, security tokens, TLS SSL certificates, encryption keys, basically any sensitive credential or cryptographic material.
Stuff you definitely don't want in your code or config files.
Absolutely not. Key Vault provides a centralized and hardened hardware security module-backed, in many cases, location for these secrets. It encrypts them both at rest and in transit, and offers really strict access control policies integrated with Azure AD to ensure only authorized users, applications, or services can retrieve them when needed. It's a cornerstone of secure application development in Azure.
Makes sense. Governance is also a huge aspect, especially as cloud use grows. Azure Policy is introduced in the materials. How does this help maintain compliance and standards?
Azure Policy is a really powerful governance service. It allows you to create, assign, and manage rules, which are called policies, that define and enforce standards for your Azure resources.
Like all storage accounts must have encryption enabled.
Exactly like that. Or only allow deployment of resources in these specific Azure regions, or mandate that all resources must have a specific tag, or even prevent the creation of certain expensive VM sizes in a development environment.
So it enforces the rules.
It does. Azure Policy evaluates your existing resources and any new resources being deployed against these policies. It can operate in two modes. It can just audit for non-compliance, reporting on resources that violate the rules, or it can actually enforce the rules by actively preventing the creation or modification of non-compliant resources.
Wow, okay. So it keeps things in line.
It's crucial for maintaining consistency, enforcing security standards, meeting regulatory compliance requirements, and controlling costs across your Azure environment. It's worth remembering, too, that while permissions applied at a resource group level are inherited by the resources inside,
Right.
resource tags are not automatically inherited. You need to apply tags directly. And another governance feature mentioned is resource locks.
Locks to prevent deletion.
Exactly. Resource locks provide a way to prevent accidental deletion or modification of critical Azure resources or even entire resource groups. You can apply cannot delete or read-only locks, and these locks apply to all users, even administrators, providing an extra layer of protection against mistakes.
Very useful for production environments. Identity management is obviously fundamental to security. Azure Active Directory, Azure AD, is discussed. What is it, and how does it fit into managing Azure?
Azure Active Directory, Azure AD, is Microsoft's cloud-based identity and access management service. It's the core identity provider for Azure.
So it handles logins.
Yes, it handles authentication, verifying who the user is, and authorization determining what they're allowed to do for accessing Azure resources, Microsoft 365 services, and thousands of other SaaS applications.
Can it connect to my existing on-prem Active Directory?
Absolutely. You can integrate your existing on-premises Windows Server Active Directory environment with Azure AD using a tool called Azure AD Connect. This synchronizes user identities, enabling a hybrid identity setup where users can use their familiar corporate credentials to access cloud resources.
Single sign-on, basically.
That's often the goal, yeah. The concept of federation is also mentioned, which allows you to use other trusted identity providers, like your on-premises ADFS, to handle the authentication process for accessing Azure resources. It's crucial to understand that Azure AD is the foundation for managing access to your Azure subscriptions. You manage roles and permissions through Azure AD identities. It's not necessarily tied to a personal Microsoft account, like an Outlook.com address, although you can use those too. And individual Azure AD user accounts can be assigned multiple licenses for different cloud services.
What about proactively identifying, like risky sign-ins, someone logging in from a weird place? Azure AD Identity Protection is mentioned.
Azure AD Identity Protection is a feature primarily in Azure AD Premium P2 that uses machine learning and behavioral analytics to detect potentially risky sign-in attempts and vulnerabilities affecting user accounts.
Like what kind of risks?
It can identify sign-ins from anonymous IP addresses, like Tor nodes, unfamiliar locations, malware-infected devices, or patterns indicative of password spray attacks or leaked credentials.
And what does it do when it finds something risky?
When a risk is detected, identity protection can trigger automated responses based on policies you configure. This might include requiring the user to perform multi-factor authentication, MFA, forcing a password reset, or even blocking the sign-in attempt altogether. It helps automate the response to potential identity compromise.
Okay, that sounds useful. We also see Azure Security Center and Azure Information Protection mentioned briefly in the security context. Quick overview of their roles.
Sure. Azure Security Center, which is now largely part of Microsoft Defender for Cloud, acts as a unified security management platform. It provides threat protection and helps you assess and improve the security posture of your Azure resources, and even hybrid resources like on-prem servers or resources in other clouds.
How does it do that?
It continuously assesses your environment against security best practices and benchmarks, identifies vulnerabilities and active threats, and provides prioritized recommendations to harden your security. It gives you a secure score to track your posture over time. Some basic features are free, but the advanced threat detection and protection capabilities are in the paid Defender plans.
And Azure Information Protection, AIP.
Azure Information Protection, AIP, is focused on classifying and protecting your sensitive data documents and emails.
Okay, data classification.
Yeah. It allows you to apply labels to information based on its sensitivity, like confidential, internal only. These labels can trigger protection actions, like automatically encrypting the file or email and applying visual markings like headers, footers, or watermarks.
And the protection travels with the data.
That's the key benefit. The classification and protection applied by AIP persist with the data, regardless of where it's stored or who it's shared with, helping to control access even when it leaves your organization's boundaries.
Okay, interesting. Finally, in this security section, the materials just quickly touch on Azure Resource Manager resource groups again, Azure Advisor security recommendations, and RBAC.
Right. We mentioned resource groups before, those logical containers for managing resources collectively. Applying permissions at the resource group level is a core part of Azure management, and those permissions are inherited down. Azure Advisor, as we discussed for cost, also provides specific, actionable recommendations to improve the security of your Azure environment based on Microsoft's best practices and security benchmarks. It might flag things like missing MFA, unencrypted disks, or overly permissive network rules.
So it helps across multiple areas.
Definitely. And Azure Role-Based Access Control, or BAC, is the fundamental authorization system within Azure. It's how you grant permissions. Instead of giving users broad access, you assign them specific roles, like reader, contributor, owner, or more granular roles, like virtual machine contributor, scoped to particular resources, resource groups, or subscriptions.
Least privilege principles.
Exactly. RBAC allows you to implement the principle of least privilege, ensuring users only have the permissions they absolutely need to perform their job functions, which significantly reduces the potential impact of compromised accounts or accidental misconfigurations.
Okay, we've covered a significant amount on security and governance, really critical stuff. Let's shift gears now and talk about the tools Azure actually gives you to manage and interact with all these services. The Azure Portal is probably the first thing most people see.
Absolutely. The Azure Portal, portal.azure.com, is the main web-based graphical user interface, GUI. It provides a centralized visual console for managing pretty much your entire Azure subscription.
Point click.
Yeah, point click. It's accessible from basically any device with a modern web browser, including, as the notes mention, Android tablets, allowing you to create, configure, manage, monitor pretty much the full range of Azure services visually. It's often the starting point for exploring Azure.
Okay. What about when you need a command line for automation, scripting, that kind of thing? Azure Cloud Shell is mentioned.
Azure Cloud Shell is a really fantastic feature for that. It's an interactive browser-based shell environment that's accessible directly within the Azure portal or via its own URL, shell.azure.com.
So, no install needed.
Exactly. It comes pre-configured with common Azure command line tools, most importantly, the Azure CLI for Bash and Azure PowerShell. You can choose which shell experience you prefer.
Convenient.
Incredibly convenient. It allows you to run Azure commands and scripts to manage your resources from virtually anywhere without needing to install or configure anything on your local machine. It even provides a small amount of persistent storage for your scripts.
So Cloud Shell is great for browser-based CLI access. What if I prefer to have the command line tools installed locally on my own computer? Azure CLI is mentioned there.
Yep. The Azure CLI is also available as a standalone tool that you can install locally on Windows, macOS, or Linux. Once installed, it lets you manage pretty much every aspect of your Azure environment right from your local terminal or command prompt or PowerShell window on Windows. This is often preferred by developers and sysadmins for heavy scripting, automation workflows, and integrating Azure management into their existing tool chains.
Got it. Automation is definitely key for managing cloud stuff at scale. Azure Resource Manager templates are mentioned for that.
Azure Resource Manager templates, or ARM templates, are super important for infrastructure as code in Azure. They are JSON files that declaratively define the infrastructure and configuration for your Azure solution.
Define everything in code.
Essentially, yes. You specify what resources you need, VMs, networks, databases, etc., and how they should be configured. Sizes, settings, dependencies, all within the template file.
And then Azure builds it.
Right. You deploy the template, and Azure Resource Manager reads it and provisions all the defined resources in the correct order, ensuring consistency and repeatability. Instead of clicking through the portal dozens of times, you define it once in a template and deploy it reliably again and again, crucial for consistent dev test prod environments.
Okay, infrastructure as code. For keeping a close eye on how everything's running health, performance, Azure Monitor is mentioned. What can it do?
Azure Monitor is Azure's core unified monitoring service. It collects, analyzes, and acts on telemetry data from across your entire Azure environment and even on-premises resources.
What kind of data?
Metrics like CPU percentage, disk IOPS, activity logs, what changes are being made, diagnostic logs, detailed logs from individual resources, application performance data, basically a huge range of signals.
And what do you do with that data?
You can visualize it in dashboards, query the log data using a powerful query language, Custo Query Language, KQL, set up alerts to notify you proactively when thresholds are crossed or specific events occur, and perform deep root cause analysis when problems arise. Importantly, as the notes highlight, Monitor can centralize logs from various Azure services, subscriptions, and even tenants into a single log analytics workspace for unified analysis.
Centralized visibility. What about getting info on, like, Azure platform issues, planned maintenance, outages? Azure Service Health is mentioned.
Azure Service Health is where you go for that. It provides a personalized view of the health and status of the specific Azure services and regions that you are actually using.
So it's tailored to me.
Yes. It shows ongoing service incidents, upcoming planned maintenance windows that might affect your resources, and health advisories from Microsoft. It's the authoritative source for Azure platform status relevant to your deployments. You can also set up service health alerts to get proactively notified about issues impacting your stuff.
Good to know where to look. We talked about Azure Advisor for cost and security. Does it help with managing Azure in other ways too?
Yes, it does. Azure Advisor, as we've touched on, really acts like that personalized consultant across several key pillars, not just cost optimization and security hardening, but also for improving performance and ensuring high availability or reliability.
So it gives tips on making things faster or more resilient.
Exactly. It analyzes your configurations and usage and provides best practice recommendations across all those domains. Things like suggesting SKU upgrades for better performance if a resource is bottlenecked, or recommending availability zone deployments for better resilience. One thing the sources note it doesn't typically do is offer specific recommendations on, say, network settings within a VM's operating system. It focuses more on the Azure platform level.
Okay. Finally, in this management tool section, Azure Dev Test Labs is mentioned. What's the main use case for this service? Sounds like for developers and testers.
Precisely. Azure Dev Test Labs is specifically designed to streamline the process of creating and managing environments for development and testing teams.
How does that help?
It allows lab owners to set policies like allowed VM sizes, auto shutdown schedules to control costs, and provides developers and testers with a self-service way to quickly provision pre-configured VMs and environments using reusable templates and artifacts.
So faster setup for dev test.
Yeah, the goal is to minimize the admin effort and wait times associated with getting these temporary environments set up, letting teams spin up what they need quickly, use it, and then easily tear it down afterwards, often with built-in cost controls.
Makes sense for those scenarios. Okay, that's a great tour of the management tools. Now let's briefly touch on Azure's global infrastructure and its approach to compliance. The materials mention Azure has a vast network of regions worldwide.
That's right. Microsoft Azure has a massive and constantly growing global footprint, dozens of regions across the planet, each typically containing multiple data centers.
Why so many?
This huge network provides scalability, redundancy. You can deploy across multiple regions for disaster recovery, and importantly, allows you to deploy your applications and data closer to your end users to reduce latency and potentially meet data residency requirements.
Okay. The sources also specifically call out Azure Germany and Azure Government. What makes these different?
These are what Microsoft calls sovereign clouds. Azure Germany is, or was, it's transitioned slightly, a specific offering designed to meet strict German data residency and compliance rules. It involved a physically separate instance of Azure within Germany, originally with a German data trustee overseeing access.
for very specific German regulation.
Exactly. And Azure Government is a similar concept, but for the US, it's a physically isolated instance of Azure built from the ground up to meet the stringent security and compliance requirements of US federal, state, local, and tribal government agencies and their partners. It has specific compliance certifications relevant to the US public sector.
Okay, specialized instances. For organizations dealing with regulations or needing proof of compliance, what resources does Azure offer? The Azure Trust Center.
The Azure Trust Center is the main public-facing website where Microsoft provides a ton of information about its security, privacy, compliance, and transparency practices for Azure and other cloud services.
What kind of info?
You can find details on Azure's extensive list of compliance certifications, like ISO 27001, SACCHO 123, HELPA, FedRAMP, GDPR adherence, audit reports, white papers, FAQs, basically documentation to help organizations understand how Azure meets various global and industry-specific standards.
And Compliance Manager.
Compliance Manager, which you access via the Service Trust Portal, part of the Trust Center ecosystem, is more of an interactive tool. It helps you assess your own Azure environment's compliance posture against specific regulations or standards. It maps Azure controls to regulatory requirements and helps you manage your compliance activity.
Okay, useful resources for compliance needs. Finally, let's talk about Azure support plans and those service level agreements, SLAs. The materials outline different support plans. What are the key differences, especially about getting help from actual engineers?
Right. Azure offers a range of support plans to fit different needs and budgets. The main ones mentioned are Basic, Developer, Standard, Professional Direct, and Premier, now often part of Unified Support.
What's the big difference for getting tech support?
A crucial distinction highlighted is access to Microsoft support engineers for technical issues. Only the Standard, Professional Direct, and Premier Unified plans provide 24/7 access via both phone and email for technical support, with varying response time targets depending on severity.
And Basic and Developer.
Basic support provides access to documentation, community forums, and support for billing and subscription management issues, but no direct access to technical support engineers. The Developer plan adds email access to engineers during business hours, but no phone support and slower response times.
So if you need engineer help, Basic is out.
Correct. The docs also note that Premier Unified Support often includes additional benefits like dedicated account management and architectural reviews to help you design better solutions on Azure. And you can always open a support request through the Help Plus Support section in the Azure portal, regardless of your plan, though what happens next depends on the plan.
Good to know. So if you anticipate needing engineer help, Basic won't cut it. What about the service level agreements, SLAs? What are they and why are they important for understanding Azure reliability?
Service level agreements, SLAs, are essentially Microsoft's contractual commitments regarding the performance and availability of specific Azure services. They're usually expressed as a minimum uptime percentage per month.
Like the 99.99% for VMs across AZs we talked about.
Exactly. That's a specific SLA. Different services and different configurations of the same service often have different SLAs. For example, single VMs with premium disks have a 99.9% SLA, while using availability sets gives 99.95%. Azure AD Premium also has its own SLA. It's really important to understand that if your application depends on multiple Azure services, like a VM, a database, and Azure AD, the overall potential SLA for your entire application, the composite SLA, will generally be lower than the individual SLAs of its components. Your app is only as available as its least available critical part.
The weakest link determines the chain's strength.
Precisely. And if Microsoft fails to meet an SLA for a service, you might be eligible for service credits, basically, a discount on your bill for that specific service for that month. But the credits only apply to the affected service, not your whole bill.
How is that uptime calculated?
The standard formula mentioned is maximum available minutes in the month, total downtime in minutes, maximum available minutes in the month, then multiply by 100 to get the percentage.
Got it. Lastly, the sources differentiate between Azure services being in private preview, public preview, and general availability, GA. What do these terms mean for users?
These terms describe the release stage of an Azure service or feature. Private preview means it's available only to a limited select group of customers, usually by invitation, for early testing and feedback. It's not open to everyone.
Very early stage.
Yes. Public preview means the service or feature is now available for all Azure customers to try out, usually accessible through the standard Azure portal or tools. However, services in public preview often come with caveats.
Like what?
They might have reduced or no SLA, support might be limited, best effort, pricing might be discounted or changed later, and the service itself might still undergo significant changes before final release. It's generally not recommended for production workloads.
So use with caution.
Definitely. It's for evaluation, testing, and providing feedback. General availability, GA, means the service is fully released, considered production ready, fully supported by Microsoft, has a defined SLA, and standard pricing applies. This is the stage where you can confidently use it for business-critical applications. You can usually manage preview services with the regular Azure tools, though.
Okay, private preview, invite only. Public preview, try it out, but maybe not for prod. And GA, ready for prime time. That makes sense.
Yeah.
Wow, that was a truly comprehensive deep dive into the Azure materials you provided. We've really covered a lot of ground.
You certainly have.
Explored everything from those fundamental cloud deployment models, public, private, hybrid, the different flavors of cloud services. Yes, PATs, SATs, critical aspects of cost management, OpEx versus CapEx,
No, keeping costs down.
ensuring availability and reliability with regions and zones, the layers of security and governance tools like NSGs, firewall, policy, Azure AD,
P-Vault, RBAC.
all the management tools like the portal, CLI, Cloud Shell, ARM templates, Monitor, Azure's global footprint and compliance efforts, and finally, wrapping up with support plans and what those SLAs really mean, plus the preview stages. It's all there, drawn right from the sources you shared.
Indeed. It covers a lot of the foundational concepts. And, thinking about all that, the different deployment models, the range of services from IaaS to SaaS, what initial thoughts do you have maybe about which approach might be most suitable for potential cloud projects? And what are some of the first security or cost considerations that jump out as you weigh those options?
Ooh, that's a really insightful question to leave us with. Definitely something to ponder. We really encourage you, our listener, to delve deeper into the specific reference links and documentation within the materials you provided. Explore these topics further, see how they fit your needs, and continue your learning journey in the, very dynamic world of Microsoft Azure. Thanks for joining us for this deep dive.